This is the first video of our last unit on electricity, and this video is on static electricity. At the end of this video, I want you to be able to say, I can explain what electricity is in terms of electrons, explain how charged particles behave when they are close to one another, and describe how objects can become charged in 3 different ways: by friction, by contact, and by induction. Let's get started on accomplishing these objectives. During this unit, we're going to talk about 2 types of electricity: static electricity and current electricity. Now this video is going to be all about static electricity, but it's important to differentiate between the two right off the bat. So static electricity is electricity at rest, and that's exactly what that word static means. Current electricity is electricity in motion, and we're going to talk about how current electricity moves through circuits. In current electricity, the electricity keeps flowing, it keeps moving, but in static electricity, what can happen is that object gets charged, that electricity stays in the object until that object is discharged. But once the object has its electricity discharged, then the object isn't charged anymore. We're going to experience that a lot with the labs and activities that we do in class. The first question we should ask is, what is electricity? And probably when you think of electricity, you think about the outlet in your wall, but what exactly is happening with that? And electricity is all about the flow, the movement of electrons. Now hopefully you remember from chemistry what an electron is, but if you don't, let's do a quick recap. Here's an atom right here, and all atoms are made up of 3 basic parts: protons, neutrons, and electrons. Now protons and neutrons are in the nucleus of an atom, and electrons move around in a cloud outside of the nucleus. Now what happens is that these electrons can be transferred between atoms or between objects, and that's going to cause some charge. Now, what is this charge? Hopefully you also remember from chemistry that protons are positively charged, electrons are negatively charged, and neutrons have no charge. So what electricity is all about is movement of electrons, of these negatively charged particles, from one object to another, from one atom to another. So it's movement of negative charges. Protons don't move. And that's going to be really important as we go through the rest of this explanation. Another key part of understanding electricity is to understand how electric charges can generate forces. And these forces can be predicted by 2 basic rules. One of those rules is that opposites attract, and the other rule is that like charges repel. And if you keep this in mind, electric forces can be relatively easy to understand. So here's the case where you have 2 balls, and they're both positively charged. Now what's going to happen, since they are like charges, the force that's going to be created on them is going to be a repellent force. Now you remember what causes positive charge? Protons are positively charged. When 2 objects have opposite charges, that's going to be an attractive force. So here, a positive charge and a negative charge, those opposites are going to attract. And finally, in this last example, both of these balls have a negative charge, and so they are going to repel each other. So if they're both positive or both negative, those charges are like, and they're going to repel. If they're opposite charges, they're going to attract. So let's put some of this together and talk about how objects can become charged with static electricity. Remember, electricity is all about moving electrons. Electrons become transferred. So objects become charged when they gain electrons or when they lose electrons. Let's look at this picture. What's happening is the red ball on the left is transferring an electron to the blue ball on the right. So after the electron transfer, now this red ball has less electrons. It's going to become positively charged. This blue ball has more electrons, and it's going to become negatively charged. So, a key thing that I need you to understand here is that an object that gains electrons becomes negatively charged. An object that loses electrons becomes positively charged. So an object doesn't become positively charged by protons moving into it. Instead, it becomes positively charged by losing electrons. Something that's less negative becomes positively charged. So, how does this happen? How do the electrons move around for an object to become charged? There's three things that we're going to have to keep track of. Objects can become charged by friction, by contact, and by induction. Let's look at each of these three separately and give some examples. First, let's talk about friction. Now, we're familiar with friction, and that's a force that happens when two objects move over each other, or two surfaces rub against each other. So, you've all experienced this. You've all become charged by friction. So friction is when two objects rub together, and that results in an electron transfer. And here's the classic example. When you're walking around with shoes on a floor that has carpet on it, what's actually happening is when your shoes rub against the carpet, you're actually picking up electrons from the carpet. And those electrons move all through your body. So, where did you get those electrons from? Those electrons transferred from the carpet to you, and you became charged. So you're becoming more negative, and the carpet is becoming more positive. So, both you and the carpet became charged by friction. Now, for sure, after you become charged on the carpet, what's happened to let you know that you're charged is that when you become discharged. So what usually happens is you touch something metal, and there's a shock, and it can be surprising. So what it actually looks like, and you could see a spark if it was really dark, but what it feels like, since it scares you a little bit, it feels like that shock is moving through your whole body. So this is an example of objects becoming charged by contact. So contact is just what it sounds like when two objects touch each other. So this isn't rubbing like friction, but just touching. So what happens is after you get charged up by the carpet, then when you touch something that's metal or something that's grounded, all of your negative charges go into that object. So here, you're all negatively charged from the carpet, and what happens is when you touch that doorknob, you discharge all of those electrons, transfer from you to the doorknob. Now the doorknob will become negatively charged, and you'd lose that negative charge. Lastly, there's charge by induction. So those first two types, friction and contact, involve two objects touching. But with charge by induction, the objects don't actually touch. Instead, the two objects are just brought near each other. And here's a classic example. So let me set it up. In this case, A and B are two metal spheres. And what can happen is if you bring a rod with a negative charge close by it, remember our two rules: opposites attract and like charges repel. So because this rod is negatively charged, all of the positives are going to move towards that rod, and all of the negatives are going to try to get as far away as possible. So in this case, all of those negatives are going to move from A to B because A and B are touching. Then what happens in part C here is the two spheres are moved a little bit farther apart. And since that rod was still there, all of these positive charges are still close to the rod, and all of these negative charges are stuck in part B, or in sphere B. Then what happens in part D, when that rod is taken away, what happens is that these positive charges, these like charges, want to repel, so they spread out all throughout sphere A. Likewise, all of these negative charges in sphere B, they want to repel, so they spread out by sphere B. Overall, what you have is a positively charged sphere A and a negatively charged sphere B. And how do they get that charge? Well, that's from the rod that was brought close to them but not touching. So that's charging by induction. One of the last things that I want to talk about is charge polarization. And the reason I want to talk about this is because it's something that probably we've all done. And that's when you rub a balloon on your head and the balloon sticks to the wall. So polarization is just like the South Pole and the North Pole, when that means like opposites. So let's look at this example. So here's a balloon that's been charged. And the reason it's got all of these negative charges on it is because it's been rubbed against your hair. So electrons transfer from your hair to the balloon, and the balloon gets negatively charged. That balloon has been charged by friction. Now you can see here, and here's a wall, that those positive and negative charges are pretty evenly distributed throughout the wall. Then what happens is when you bring that negatively charged balloon close to the wall, what happens is that all of those positive charges of the wall want to be close to that negatively charged balloon because opposites attract, and all of those negative charges want to move away. So what ends up happening? Since these opposites attract, that's how the balloon can stick to a wall after you rub it on your hair. This is an example of charge polarization. So what's charge polarization? Well, that's when a charged object is brought near another object and the charges get redistributed. Here, the charges are randomly redistributed. Then, once a balloon gets brought close, those charges are redistributed. The last slide that I want to talk about is to introduce a lab that we're going to do in class. And that has to do with charging up rods. So we're going to charge up two different types of rods, rubber rods and glass rods. And how we're going to charge them up is by rubbing them with different objects. We're going to rub the rubber rod with fur, and we're going to rub the glass rod with silk. So what's going to happen? We're going to be charging by friction. But what happens to the rod depends on the material that the rod is made up of, and it depends on the material that we're rubbing it with. So, in the case of the rubber rod, what happens is rubber likes to hold on to electrons more than fur. So, fur is going to lose electrons to rubber. And what's going to happen? Well, fur loses electrons. So fur is going to become positively charged, and the rubber gains those electrons. So rubber is going to become negatively charged. Now in the case of the glass rod, the glass doesn't hold on to electrons as well as the silk does. So the silk is going to be stealing those electrons from glass. Since the glass rod loses electrons, it's going to become positively charged. And since the silk gains electrons, it's going to become negatively charged. So this is a little introduction to static electricity. Over the next couple days, we'll be doing some demonstrations in lab so you can see this in action. But this video was an essential first step so that you can get a background understanding of what you're going to see.